All right, with one method accepted sampling, the sample is randomly selected without replacement, and the entire batch is accepted if every item in the sample is okay. So company manufactures that many CDs, those are defective. 3 are randomly selected. What's the probability the entire batch will be accepted? Does the outcome suggest the entire batch consists of good CDs? Why or why not? Okay. So what's the probability that the first CD is okay? So for the whole batch to be accepted, we need all 3 CDs to be okay. So what's the probability the first one's okay? How many good CDs are there? Well, there's 893 total, and 141 of those are bad. So there's 754. No, so you're right, 752. So 752 out of the 893, that's the probability that the first one's okay. Okay. And then we're not putting it back. So what's the probability that the second one's also okay? Okay, so I like the 892. We've taken one CD out, so the 893 jumps down to 892. What about the top, though? So what type of CD did we take out? Did we take out a good one or a bad one? Well, if we took out a bad one, then we're dead already. So I want to find the probability that all 3 of them are good. So yeah, if we took out a good one. And my thing quit writing again. 751. Again, it's like if you want the probability of A and B, well, you do the probability of B and then the probability of A given B. So if I want the probability both are good, I do the probability the first one's good and the probability the second one's good, given that the first one was good. So that's why we go ahead and say, okay, well, when we do the second one, we assume that the first one was good. And same thing, now we need to multiply by the probability that the third one's good, given that the first 2 were both good. So what's the probability the third one's good if the first 2 were both good? There you go, 750 over 891. All right. So we got on top 752 times 751 times 750 over 893 times 892 times 891 is that. So 3 decimals, so it would be a 7 right there. Whoops. So if we didn't know going in that actually 141 of them were bad, if I say, okay, I did this little sample, the 3 were good, would you think that's enough to say that the whole thing was good? Why not? Yeah, I mean, there's, okay, what were you going to say? Yeah, I mean, that seems like pretty low odds, but let me see what this is. Probability. I don't really like the way that words that, but that's, I mean, it's true. But, I mean, So if you had probability 1, then you would know, okay, the whole batch is good. We only have 60. In real life, you'd probably say 90 is probably good enough. But anyway, I figured they would probably go for about 95 or so. That tends to be what's common in this book. But anyway. Okay, so we got a bunch of people. 2 deaths are randomly selected without replacement. What's the probability they both involved intoxicated drivers? All right, so that's not too bad. So, okay, there we go. So it says, what's the probability they both involved intoxicated drivers? So either one can be intoxicated. So how many do not have intoxicated at all in it? Yeah, it's just the 108 where they're both not intoxicated. So there's 2 things you could do. You could add up the other 3 and divide by the total. That's the direct thing. Or you can find the probability that nobody's intoxicated and then do like 100% minus that. So either way. Let's go ahead and do the other one. I shouldn't have done that. I should have just said, okay. That one plus that one plus that one plus that one. And then equals that divided by, well, all 4 of them. That one plus, okay, 29. When there's only 4 numbers, it's always like, well, would it be faster to just actually add them, or do I want to take the time to type the word sum? So that's the probability that at least one person in the accident was intoxicated. Again, the other thing we could have done, I mean, that's the answer right there. The other thing we could have done, we could have just done, okay, 108 divided by the sum. So that's the probability that nobody involved was intoxicated. So if I go 1 minus that, that's the probability that at least one person was intoxicated. But you can go about it either way. It's okay.
How did you do that number below
Whoops. What did I do? Oh, sorry, I didn't read the question right. Okay, what did Taylor ask first? Let me go ahead and answer your question.
How did you get the number below the 91?
Number below the 91.
I said 91 because that's what's on mine.
Oh, the 66?
Yeah.
So that's just the 66 divided by all 4 of them together. Okay. So let's go back to the problem and actually read it this time. Okay, it says if 2 different deaths were randomly selected without replacement, find the probability they both involved intoxicated drivers. Okay, so we just did one event, one crash that involved intoxicated drivers. So that's like the first half of it. For the second crash, well, since it's without replacement, we're going to lose 1 off the top and 1 off the bottom, right? So this was 66 out of, I don't even know what the sum was. Let me see, the sum of all of them. So the first one was 66 out of 174. The second one is 65 out of 173. Right. And then if you want both of them to happen, well, just multiply them together. Yes, I'm going to automatically delete it for me. Oh, what's the deal? That adds up to 59.66 out of 174. $66 times 65 over 174 over 173. That's true. Read the question one more time.
Are we figuring in non-bucket hours?
Oh. So the problem was, I helped a student with a problem that had a very similar setup yesterday. And when I read this one, I thought, oh, it's just like that one. Okay, you're right. We don't want just an intoxicated person. We want only the driver is intoxicated are the only ones who work out. Okay, sorry. All right, one more time. So driver intoxicated is only the 7 and the 12. So it's 19 out of 174. And then the second one will be 18 out of 173. So thanks, Zachary. I don't know what I was thinking. All right. No, this one. So driver intoxicated is actually only 19. And then for the second crash, 18. So 0.011. And if it's not right this time, I'm going to hit something. Okay, fine. Is such an event likely? If I look at it, that is less than 0.05. So yes, that is unlikely.